And finally, we're just going to go through some more examples related to reference angles and really trigonometric functions of any angle. Okay, so we're given this bit of information, find sine and tangent. So again, I like to get a diagram going first. Okay, so I know cosine theta is positive, so that means I'm in quadrants 1 or 4, but sine is negative, so that actually tells me we're there. So the angle theta is here. Okay, and I know it has x coordinate. Actually, you can view it two different ways. You could say the x coordinate is 1 and then or 1/8, and then the y coordinate is 0 or unknown. Or you could say, adjacent side is 1, hypotenuse is 8, tomato, tomato. It'll work out either way. Okay, let's go with this approach for now because I already have it labeled, right triangle. Okay, so then to figure out the vertical side, right, I would do the Pythagorean theorem 1 squared plus y squared is equal to 8 squared. Okay, y is equal to square root of 63. Okay, you can simplify that for sure if you want. Okay, and technically it's plus and minus, right? It as a triangle, it would be positive. Since we're overlaid into a coordinate system, I'm going to go with the negative because we are in the values where y is negative. Okay, and then with that, I can just say, okay, well, sine of theta. Okay, technically, again, I'm doing theta prime. Okay, but sine of theta is equal to sine of theta prime. These things are equal as long as you incorporate the sine. Okay, so this is equal to the y value, so negative square root of 63 all over 8. Okay, so there we have sine. All right, and then lastly, it says to find tangent. So let's do tangent of theta. Again, tangent of theta prime. Okay, they are the same as long as I incorporate the sign. Tangent would be a negative number, which I already have included here. So negative y, negative square root of 63, all over x, which is 1. Okay, so there we go. All right, so key thing with that one, get it set up somehow, use your definitions, make sure to incorporate sine. Again, reference angles or trigonometric functions of reference angles are the same as trigonometric functions of just the corresponding angle, as long as we incorporate the sine. All right, so tangent. Let's actually have you pause the video, try this one out, and resume the video when you're ready to see the solution. And here's how I went about my solution. So I said tangent is positive, right? Cosine is positive, so that means my angle is in quadrant 1. And again, that would be the same as my reference angle. So technically in my solutions, I probably should say sine of theta is equal to sine of theta prime, just to acknowledge that, or sorry, this would be cosine. Acknowledge that reference angles, or trigonometric functions of reference angles or the normal angle are the same up to a sine difference. Okay, but I digress. So I labeled my triangle. I went with the triangle approach, embedded in the Cartesian plane, found the hypotenuse to be square root of 61, and then did opposite over hypotenuse for sine and adjacent over hypotenuse for cosine. There are other approaches. Maybe your brain was like, oh my gosh, I'm given tangent, and I just remember because it was beaten into my brain somehow that 1 plus tangent squared theta is equal to secant squared theta, and then you say, okay, actually secant squared is 1 over cosine squared theta. So maybe you took more of an algebraic approach and avoided the graph altogether. That's fine. Just be careful. 1, remember your signs. 2, and 3, any mathematical approach is fine as long as the instructions don't say do this, right? If the instructions say do this, then do this, right? So there we go. Last example. Okay, so we're given that a is positive, secant of theta is a negative value, and cosecant is positive. Okay, find the values of the other trigonometric functions in terms of a. Oh, okay. So I'm just thinking, a, s, t, c. Okay, so secant is negative here and here. cosecant is positive. Cosecant is the reciprocal of sine here and here. So I'm actually going to be in quadrant 2. Okay, so if I need a little sketch, here's my angle theta. Here would be theta prime. I could make my triangle and say, okay, well, secant is negative a, so hypotenuse is 1, adjacent side is negative 1, okay, negative due to direction. It's not that, it's a triangle, it can't actually have a negative side. But in any case, we have y, I could find y, okay? I do a squared is equal to y squared plus negative 1 squared. So then solving, so we'll have a squared minus 1 is equal to y squared, square root both sides, plus or minus, okay? And in this case, we're going to say that y is positive square root of a squared minus 1, or sorry, negative square root of a squared minus 1 because of the quadrant. And again, just before I go further, I did it mentally, I maybe didn't write it down, but secant of theta was negative a over 1. Well, negative a, which I could divide by 1, which would be r over x. Okay, so we have secant of theta is equal to negative a. That was given, right? And then I can say cosine of theta is negative 1 over a, right? And then sine, not cosine, sine theta, cosecant theta, tangent of theta, cotangent of theta, okay? And now I can use my diagram to help me out. So sine of theta would be, again, I'm using theta prime because I'm incorporating the sign, negative square root of a squared minus 1 all over a. Take the reciprocal for cosecant, square root a squared minus 1. Tangent is negative square root of a squared minus 1 all over a. Just kidding, negative 1. And then cotangent would be the reciprocal, negative 1 over square root of, negative square root of a squared minus 1. Okay, and again, simplify as you desire. Okay, but that's the idea. So, and again, in all of these, when you make a diagram and you're using a triangle, again, you are using reference angles. You're maybe just not fully recognizing it mathematically, and that's okay. But whenever possible, make note that, yeah, actually this is sine of theta prime, okay? But it happens to be equal to sine of theta as long as I incorporate the sign like SIGN into what I'm doing.